the quotient rule is going to be easier to spot if we go over what's not a quotient rule first. So not a quotient rule would be like 5 over x to the 4th. We only have x's in the bottom there, so we would just rewrite it as 5x to the negative 4. And then we'd take the derivative by bringing down the power and subtracting 1 for the new power. We'd get negative 20x to the negative 5th. Or conversely, we could only have x's in the bottom. We could have x to the 4th divided by 5, which is really the same thing as 1/5 x to the 4th. And we would know to bring down the power and subtract 1 for the new power for that as well. These both just end up being basic derivatives. If you only have x's in just the top or the bottom, it's not a quotient rule. What is a quotient rule would be something that has x's in both the numerator and the denominator. So I'm going to say it has x's in the top and the bottom. And we're going to write how we use that rule. The derivative of that would be the derivative of the top first times the original bottom minus the derivative of the bottom times the original top all over the original bottom is squared. So looking at these quotient rules below over here, everything has x's in both the top and the bottom. So we're going to use the quotient rule for all 3 of these, unlike our not examples up there where they only have x's in the top or the bottom. Has to have x's in both places, then we know to use the quotient rule. So my derivative of the whole thing is going to start with the derivative of the top. So derivative of 6x cubed, 6 times 3 is going to give us 18x squared. Derivative of negative 63x is negative 63. And the derivative of 9 is 0. It's a constant. There's the derivative of the top, gets multiplied by the original bottom. 2x to the 10th minus 14. Minus the derivative of the bottom. Bring down the power, 2 times 10 is going to give us 20x to the 9th. Derivative of negative 14 is 0. So there's the whole derivative of the bottom. It technically doesn't need parentheses because it's just one term. I always put them on those, so I'll put that on there. Times the original top is 6x cubed minus 63x plus 9. So there's the derivative of the top, the original bottom, minus the derivative of the bottom times the original top, and then it's all over the original bottom gets squared. So 2x to the 10th minus 14 gets squared. We can apply that rule to the one below that as well. My derivative of f is going to be labeled as f prime. And I usually set up my own parentheses. I'm going to have the derivative of the top, the original bottom, minus the derivative of the bottom, times the original top, all over the original denominator gets squared. So let's fill in these pieces. We start with the derivative of the top. I always say work your way from the top to the bottom. So derivative of 2x to the 8th is going to be 16x to the 7th. Derivative of negative 17x is negative 17. Derivative of 3 is 0. It's a constant. There's the derivative of the top. It gets multiplied by an original bottom, e to the x minus 4x. Minus for quotient rule, the derivative of the bottom, derivative of e to the x is e to the x. Derivative of negative 4x is negative 4. So we did the derivative of the top, original bottom, minus the derivative of the bottom gets multiplied by the original top, which is going to be 2x to the 8th minus 17x plus 3. All over the original denominator gets squared, e to the x minus 4x. So last one, we're going to do the same exact order with this last one here. We're going to call it f prime of x. I'm going to give myself the same parentheses. Every quotient rule has an answer that's also a quotient, so I'm going to make a big quotient here. We're going to have the derivative of the top, original bottom, minus the derivative of the bottom, times the original top, all over the original denominator gets squared. So the derivative of the top, 4 to the x, is ln of 4 times 4 to the x, minus the derivative of e to the x is e to the x. There's the whole derivative of the top. That gets multiplied by the original bottom, ln of x plus pi. Now the derivative of the bottom, derivative of ln of x is 1 over x. Derivative of pi is 0, it's a constant. That gets multiplied by the original top, which is 4 to the x minus e to the x, all over the original denominator, ln of x plus pi, gets squared.